What is up, Algebra 2? Tokar here with another midterm review. This is topic number 3. Write it down on the top of your page with your name and the page number. We are going to talk about using square roots to solve quadratic. So when a quadratic only has an A term and a C term, we get to take shortcuts. We don't have to worry about that factoring nonsense or the quadratic formula. We can use square roots to solve them, and there's only a couple things we need to remember before we begin. First off, quadratics, they can have two real solutions. They can have one real solution, or they can have two imaginary solutions. We're going to see just when each one of these might happen. Second, whenever you take the square root of a number, remember, you get two answers, not one, you get two. If we look over here to the right, we have x squared equals 9. We took the square root of both sides, and when we take the square root of 9, we don't just get 3, but we also get a negative 3. Remember, we have that fancy symbol plus or minus 3, which just means the same exact thing as listing our two separate. Second thing we need to remember is when we're solving equation with squares, with the little baby 2's, in order to remove a square from a variable, like this x squared, to get rid of this squared right here, we're going to use square roots to turn it back into an x, but we just need to make sure to do it to both sides. Now focus up. We have been struggling with solving an equation, so this is some awesome practice. On to our examples. Get any of this information down on your paper, and let's go on to the first example. Two examples. We are going to use square roots to solve these quadratics. So our goal is always to end up with x equals a number. Our goal is to end up with x equals something. Okay, and we might have more than one something. We might have a positive and a negative something. Okay, our goal is x equals. So let's start off by drawing our waterfall. Remember, we quack like a duck. Wah. Here's our waterfall. Our goal right now is to first get x squared all by itself. This x squared, it needs to be by itself. If not, we can't make any progress. So I have two things I got to get rid of. I got to get rid of this positive 4, our adding 4, and I got to get rid of this negative 3. Now, we always want to do order of operations backwards. Usually, we multiply before we add or subtract, but we're going to do the opposite. Since we are adding 4 onto the left side of the equation, the only way to get rid of this is to subtract 4 on both sides. Whatever you do to one side, do not forget to do it to the other side. On the left, 4 minus 4 is 0, so we cross it out. And we drop down the negative 3x squared. Write our equal sign in the middle on our waterfall, and we subtract 12 minus 4 gives us 8. Next, we're going to divide both sides by this negative 3. We still need to get our x squared all by itself. The only way to get it by itself is to divide our negative 3. Divide both sides by negative 3. Divide both sides by your negative 3. Now, when we divide both sides by negative 3, this cancels out, and we're left with just x squared equals 8 over negative 3. Now, in this specific example, we're going to get a gross, nasty decimal, but our goal here is not necessarily finding our two solutions. We want to know what type of solutions does the quadratic have. So, if I were to round this decimal, negative 2.7, the only way to get rid of this squared is by taking the square root of both sides. And when I take the square root of both sides, I get x on the left. And now, when I try to put this into my calculator, the square root of negative 2.7, we're lagging, 2.7, let me refresh. I get non-real answers. And what does that tell us? That tells us that this problem has two imaginary solutions. If we look back at those notes, 2 imaginary solutions happens when we take the square root of a negative number. Second example. Same thing, we're solving this for x. We need to get x equals a number, and we're going to figure out what type of solutions does the quadratic have. So draw your waterfall. Our goal is to get x squared by itself, but we have x squareds on both sides. So our first goal is to get these two x squareds together. So in order to move an entire term without breaking up the party, I need to do the opposite. This is a positive 3x squared. So I'm going to subtract 3x squared on both sides. I want to make sure I subtract it from its buddy, the other x squared. And I'm going to go ahead and subtract. 12 minus 3 is 9. Bring down the minus 12. 3 minus 3 is 0. We cross them out, and we're going to bring down the positive 24. Now I got my x squareds all onto one side, and my goal is getting this x squared all by itself. Right now I have this pesky minus 12 and this 9 in the front. I'm going to do my orders of operations in opposite order. So I need to move this minus 12. Since we're minusing a 12 on the left side, we want to add 12 to get rid of it. If we add these up, it's 0, so that checks out. Add 12. On the left side, they're gone. And we're going to drop down the 9x squared. Draw our equal sign on the waterfall and add. 24 plus 12 is 36. Now, just like we did on this side, to get rid of our number in front, we divide both sides by 9. 9 divided by 9 is 1, so that leaves us with just our x squared equals 4. 36 divided by 9 is 4. Now we're almost there. We almost have x equals a number. Right now I have x squared equals a number. And the only way to get rid of a squared is by square rooting both sides. When I take the square root of x squared, I get an x. And here's where it's tricky. Do not forget, when you take the square root of a number, you get 2 answers. The square root of 4 is not just 2, but also negative 2. These are my solutions, and this means we have 2 real solutions. So just before we end, if we go back, make sure you have this all down. If I go back, I'm going to have 2 real numbers when I have the square root of a number that's positive. Now you may be like, well, Tokar, when will I only have 1 real solution? This is really rare. It doesn't happen very often, but you will only have 1 real solution if you take the square root of 0. That's because if we take the square root of 0, you can't have a positive and negative 0. You'd only have 0, meaning we'd only have 1 solution. That's everything for the third topic. Thanks for watching. Tokar is out of here.